As far as rock mechanics is concerned, the physical and mechanical properties are very important. In last lecture, I have taught you about the physical properties. Now we are going to study mechanical properties. Mechanical properties are described as engineering properties. On the basis of these properties, it is easier to an engineer to fix the design parameters for civil engineering construction. First property, that is strength. The ability of a material to resist externally applied load is known as its strength. However, in rock mechanics, strength may be defined as the force per unit area required to bring about rupture in a rock mass at given environmental conditions. In addition to the environmental conditions, rock strength depends on 1. Size of rock specimen, type of test, duration of test, that is the rate of loading, loading condition, cycle of loading, confining pressure, degree of saturation, physical characteristic of rock material. Strength may be classified on the basis of type of loading and the stresses. 1. Compressive strain, B. 2. Tensile strain, third one is shear strain. Compressive strain of various rocks, I am giving you dry unconfined compressive strain. It is measured in kg per square centimeter. First rock, that is a igneous volcanic basic rock, that is a basalt, and its unconfined compressive strain is 1500 to 3000. Then gabbro, it is a basic plutonic rock, which one is showing granitic texture, and strength is, compressive strain is 1800 to 3000. Then granite, which one is a acidic plutonic rock, strength is 1000 to 2500. Limestone, limestone is an organic deposit, strength is 300 to 2500. Sandstone, sandstone is a arenaceous sedimentary rock, whose strength is 200 to 1700. Shale, it is a sedimentary argillaceous rock, means which one is composed from clay. It is size, particle size or sediment size is less than 0.01 millimeter, and strength is 100 to 1000. Gneiss, it is a metamorphic rock. It may be gneiss, may be granite gneiss, may be hornblende gneiss, any gneiss, metamorphic rock. Strength is 800 to 2000. Then marble, strength is 1300 to 2000. Quartzite, it is an older sandstone, strength is 870 to 3600. And slate, the slate is the product of cataclastic metamorphism of argillaceous rock shale, and strength is 1000 to 2000 kg per square centimeter. Then tensile strength, it is again measured in kg per square centimeter. Tensile strength of basalt is 60 to 120, gabbro 50 to 80, granite 40 to 80, limestone 10 to 70, sandstone about 20, shell 20 to 100, gneiss 40 to 70, marble 50 to 80, quartzite 30 to 50, slate 70 to 200. This is about the strength. Then next property, that is deformability. The capacity of the rock to strain under applied load or in response to the removal of a load for a perfect performance of the structure made over the rock mass. It is necessary to know how much deformation it takes under loading system. Deformability of rock depends on the type of a rock, various rock defects, degree of weathering, type of load, state of stress within the rock mass, elastic and rheological properties of rock. Then next property, that is the elasticity and plasticity. The property of a material to recover the deformation is known as elasticity. The limit up to which the material is elastic to the deformation is called as elastic limit. The linear relation between the stress and strain is known as Hooke's law. Property of elasticity of rock depends upon its continuity, homogeneity, and isotropy. Plasticity, it is a property of solid material to reform continuously and permanently without rupture under stress. Rock also behave elastically at an ordinary temperature and pressure, but they may deform at higher pressure and temperature. Then next property, that is hardness. This is the last mechanical property. Hardness of rock is defined as its resistance to abrasion. This property helps in estimating rock decay when put to odd conditions. It is also given an idea of strength gradation of rock. It depends upon the strength of chemical bond between the minerals. It affects reliability of rock. This is about the mechanical properties of the rock. Now, as far as the rock mechanics is concerned, the lab test and field test are very important. So, we are going to study the rock testing in laboratory. How the testing is carried out in laboratory. Rock testing in lab includes sampling, sample preparation, specimen. So first, sampling. First, sampling. Rock in general is non-homogeneous and properties of rock samples taken from one portion of the rock may be different from the other. Therefore, samples collected must truly represent the rock mass. To ensure proper sample, some points must be kept in mind. First point to be kept in mind is lithological studies, mineral composition, nature of cementing material as far as the sediment rocks are concerned, and texture. Second point, existence of bedding planes and their identification. Third point, presence of planes of weaknesses, that is, cleavage planes, joints, cracks, fractures, planes of schistosity, etc. And last point, presence of faults, dikes, folds, etc. Then sample preparation. How to prepare samples in lab or for testing. Samples for laboratory testing are collected in the form of large blocks from the field. Out of these samples, test specimens are prepared for a particular type of testing. While collecting samples, some care should be taken. So, first, samples of hard rock are taken by drilling, which should be closely spaced and should overlap either drill holes. Then second, soft rock should be given careful treatment. Blasting should be avoided before drilling. Cracks developed due to blasting in core may mislead the result. Diamond drilling should be used to take samples from greater depth. Collected samples should be marked on the map to indicate their original position and orientation. Then third point, that is specimen. In laboratory, test samples are to be prepared for a particular laboratory test. The shape and size of the specimen depends upon the type of test. To determine mechanical properties of specimen, it has to be traced in a regular size and shape suitable for testing. Most of the specimens are of cylindrical shape. Prismatic and cylindrical shape are also required for specific tests. A specific ratio of testing sample should be maintained. For compressive strain test, it should be 2:3. For bending test, it should be 3:7. And for Brazilian test, it should be 0.5:1. End core should be cut by disc saw and should be finished by a surface grinder. This was about the mechanical properties and testing procedure in laboratory. Now we are going to start very important part, that is a rock mass classification. Several classification systems have been developed, but none is universally accepted. However, because of fact that the earth material behaves differently to dynamic load and to static load. However, it is found necessary for engineering purpose to schematize or classify the rock masses. Their behavior to different factor of influence. A good classification system shall be simple, clear, and have common terminology, significant properties, and parameters that can be measured easily and quickly, which can be used for design and should be general enough to apply for tunneling, foundations, and floors. Aim and objective of rock mass classification systems are to provide a base for understanding the characteristics of each group, to divide a particular rock mass into groups of similar behavior, to yield quantitative data for engineering design. These are the aim and objectives of rock mass classification system. All classification systems are based on data generated from investigation stage to construction stage. Some basic information should be available invariably. So very important information is about geology, that is the lithological composition, tectonics, weathering, and decay. Second, discontinuities, that is joints, number of joints, joint set, fissures, fractures, etc. Physical and mechanical properties are also important. Initial stresses, initial stress stage, groundwater condition, that is occurrence of groundwater, its level, direction, and rate of flow and quantity, etc. Type of engineering work, that is type of structure, dimension, shape, orientation, etc. Thank you.